Hello. Today I'm going to be talking a bit about chain of thought. A while ago, it was a hot topic in the AI space, and now people have kind of moved past it, but it's very foundational, and anyone who has a deep interest in AI needs an understanding of this. So, what is chain of thought? Chain of thought refers to when an LLM generates a sequence of reasoning steps before producing a final output, like when humans think and reason before they act. For example, if I ask you a question like, if I have 10 cookies, then eat 5 cookies, how many do you have left? You need to reason a bit to answer this question. We need to say, okay, we have 10 cookies, then we eat 5. 10 minus 5 is 5, so we have 5 cookies left. And if you ask an LLM that same question, it'll probably give you the right answer. But how can these language models think like we do? To examine this, let's look at an old model of GPT released in 2019, GPT-2 Medium. Let's go ahead and write our prompt. Normally for GPT-2, we give a few examples and then ask it to complete the prompt, since this is a completion model. We'll give it an example, and then we'll ask our question. Tom has 4 candies, Mary gives him 4 more. How many candies does Tom have now? The answer is blank. GPT-2 will fill this in for us when we prompt it. Like I said earlier, it's a completion model. But what happens if we write our prompt in a slightly different way, in the style of a chain of thought? We'll give it the same example, except this time in the example, we'll include intermediary reasoning steps for the LLM to see, along with the keywords, let's think step by step. Now, when we ask our question, instead of writing the answer is blank, we write let's think step by step. Now, when we go ahead and try this out, we'll see that with the normal prompt, GPT-2 fails to answer the question correctly. But with the chain of thought prompt, it does. And by the way, when we write one example like this before our actual question, this is called a one-shot prompt. If you had K examples, then it would be a K-shot prompt. Let's go to our computer and run these prompts to see this actually happen. So here we have a chat interface open for GPT-2 Medium. Let's go ahead and run our prompts, starting with the normal prompt. I decided to give 2 examples instead of just the one I showed on the whiteboard, so this would be a 2-shot prompt. With the normal prompt, we see GPT-2 gave us the wrong answer, 6. The correct answer would have been 8, because 4 plus 4 is 8. In a fresh chat, let's type up the special chain of thought prompt, again with 2 examples, also a 2-shot prompt. We see that with the chain of thought prompt, GPT-2 produces step-by-step reasoning and then was able to give us the correct answer, 8. You might think that it's a little silly, we just gave it 2 examples of step-by-step thinking, so no surprise it also thinks like that. But our model was able to take our examples and generalize it to a new case, producing coherent step-by-step reasoning for a question it has never seen before. Now let's head back to the whiteboard. We just saw that when we get a model to produce a chain of thought, we get better results. Before we talk about how to produce a chain of thought and get better results, let's examine how a model is even able to produce a chain of thought. To think about this, we need to first look at how a prompt moves through an LLM. When you give a prompt to an LLM, it is first split into tokens. Tokens are words or any string of text. And these tokens sort of act like a dictionary, defining the vocabulary. All of the tokens are converted then into embeddings. The embedding of each word represents the semantic meaning of that word. After the tokenization and embedding process, we begin the real computation. What happens next is we take the embeddings and we feed them into something called the attention mechanism. The attention mechanism takes the embeddings of the words, and it captures the meaning of those words in context. For example, the word bark can mean tree bark or like a dog bark. A dive into how the attention mechanism does this is not in the scope of this video, but the core thing the attention mechanism does is it looks back at previous words to capture the meaning in context. By looking backwards, this is akin to reflexive thought, which is one of 2 mechanisms needed for high-level reasoning. What happens after attention is also not in the scope of this video, but it basically does a bunch of things and comes up with a prediction for the next token. So we took the prompt, did all of these things, and now we got the next token. When you chat with an LLM, it produces a long output usually, not just one token. It does this by taking that token, appending it to the end of the prompt, and then going through the entire process of next token prediction again, eventually until some stop condition. So from this, we see that the model goes through this repeated process of generating tokens one by one. This repeated process is called autoregression. The model builds its response one piece or token at a time, using everything it has built so far to decide the next token. This autoregression is akin to sequential thought, the other mechanism needed for high-level reasoning. Attention enables reflexive thought, while autoregression enables sequential thought. These are the two mechanisms needed for reasoning, and our LLM has both of them. So we could see that it is able to reason. But how does that reasoning actually come out? LLMs weren't trained to reason, they were trained to predict the next token. So why does it reason? Chain of thought and reasoning is an emergent behavior of LLMs. And the reason it emerges is because it's useful to the task of next token prediction. In trying to predict the next token, the model found it useful to use intermediary reasoning steps, likely because logic and reasoning helps predict the next word more accurately. The model is not built to reason, but learns the structure of reasoning because that improves its training objective, which is next token prediction. This also means that this chain of thought is not based on logical accuracy, but it's based on accuracy of next token prediction. And this also only happens in models of large enough scale. Learning to think step by step only becomes statistically rewarding at a large scale. So we saw that there are three main things related to the emergence of chain of thought in LLMs. The architecture, namely autoregression and attention, the training objective, which is next token prediction, and prompting and training. Chain of thought is enabled by the architecture, shaped by the training objective, and elicited with prompting. So far, we've only seen eliciting chain of thought with chain of thought prompting at the beginning of this video. But when you go and talk to ChatGPT today, you'll find it always does this, because these companies use clever techniques to enhance chain of thought. The first most basic thing they do is they separate the chain of thought reasoning from the final answer, which creates an impression that the model is reasoning internally. When you see ChatGPT saying thinking, that's what it's doing. This is mostly just for appearance though, and there are four major ways in which companies enhance the quality of chain of thought. The first way is through chain of thought training. Models are trained on examples that include explicit intermediary reasoning steps, so during next token prediction, they are likely to produce a chain of thought. This is the most basic way to elicit chain of thought without chain of thought prompting. To enhance the quality of chain of thought, one technique they use is self-consistency. This is basically where the model generates multiple different reasoning chains and outputs, then the most common one is selected. This is a simple way of improving the quality of chain of thought. Another way is through a technique called tree of thoughts. This is similar to self-consistency, but it doesn't generate multiple complete outputs. The model generates different paths of chain of thought and scores the paths to select which one to continue down. Another prominent one is called reinforcement learning. In essence, the model is penalized for a bad chain of thought and rewarded for a good chain of thought. Companies typically use reinforcement learning with human feedback, or RLHF, to determine what is good versus what is bad. So, what did we learn? Chain of thought is when a model generates intermediary reasoning steps before outputting an answer. This is what ChatGPT is doing when it says thinking. We see that when a model does this, it improves its accuracy. We also saw that chain of thought is enabled by attention and autoregression. But chain of thought isn't some special trick we coded into language models. It's something that emerges when a model gets large enough and smart enough to realize that reasoning helps it predict the next word. The ability to think step by step, to look back at what it just said, and to build on it. All of that comes from the same simple loop of next token prediction and attention. That's really what makes this so amazing. From a simple task, next token prediction, comes something that starts to look like human thought. It's a reminder that intelligence doesn't always come from complex design, sometimes it emerges from simple rules scaled up. Thanks for watching, and remember, what looks like reasoning may just be calculation done really, really well.